Find the Laplace transform of a polynomial f of t equals t to the power of n. We got the Laplace equation, and we're going to replace f of t with t to the power of n, integral 0 to infinity e to the power minus st t to the power of n dt. We're using integration by parts, where u equals t to the power of n du dt will be n t to the power of n minus 1, and dv dt will be e to the power minus st. Multiply both sides by the t, and you get dv equals e to the power minus st dt. And we integrate both sides, we get v. If you integrate exponential, you get exponential back, divided by the derivative of the exponent. And now we're going to substitute everything back into the integration by part. So let's write the integration by part, which is integral of u divided dt equal to uv minus integral of v du dt. We need to go from 0 to infinity. Again, 0 to infinity, and square bracket there, 0 to infinity. That's for definite integral. And we can write the Laplace for this integral, and we know what u is, t to the power of n, and we know what dv dt is, and now we're going to open bracket or square bracket there, 0 to infinity minus the integral 0 to infinity, v is e to the power minus st over minus s times the n t to the power n minus 1. And we need to substitute t for infinity and t for 0. So infinity to the power of n, that's 1 over e to minus s, obviously, on the e to the power s infinity, minus e to the power 0, well, 0 to the power of n, e to the power 0 minus s over minus s, minus the integral of 0 to infinity e to the power minus st over, so that's plus, if I take the n and s out, that's it. And so that would be the Laplace of t to the power of n, and we're going to write that again, t to the power of n Laplace is equal to, well, that will be 0 minus 0 and n over s integral of 0 to infinity e to power minus st t to power n minus 1. But I to subscript n represents the Laplace of t to the power of n. You can see that's similar to the Laplace of t to the power of n minus 1. So we can say n over s and replace that with I subscript n minus 1. So we're going to integrate the I subscript n minus 1 now. And if we integrate that, we're just going to replace n with n minus 1. And that will be n minus 1 over s. And we're going to get I subscript n minus 2 because we replace n with n minus 1. Again, we're going to integrate I subscript n minus 2. We then get n minus 2 over s. This time I subscript n minus 3. So that goes on until we get, let's do another one. I subscript n minus 3. That'll be n minus 3 over s subscript I subscript n minus 4. And then until we get to 1. How can we get 1? Well, if we write I subscript n minus n minus 1, because that will be 1. So we're going to get n minus 1 over s, and the I must be 0, because if that was 1, the subscript will be next to it will be 0. So let's find I0, which is t to the power of 0, because n is 0 now. So t to the power of 0, because n is 0, so that's in is 0. The n is 0. So we're going to get t to the power of 0 is 1. So Laplace of 1 will be 1 over s. Laplace of a constant is Laplace of a will be a over s. Laplace of 1 will be 1 over s. Laplace of 2 will be 2 over s. So now let's put that together. In will be, we're going to replace all the subscript now because we're multiplying them. So it's going to be n over s times the in subscript 1, which is n1 minus n minus 1 over s, times n minus 2 over s, times, and it goes all the way to 3, to 2, to 1, and then you get I1, which is 1 over s. So that's 3 over s, 2 over s, 1 over s. Then the last one will be I0, which is 1 over s. And so if you look at the top, there is n factorial. That's n factorial. How many s's do we get? We get s at the bottom, s to the power of n, all the way to 1. And then for the 0 is 1 over s. The I0 is 1 over s. So that's it. And so if we put it together, that would be n factorial times 1 is n factorial over subscript. You add them together, same base. And so you get n plus 1. So the in is the Laplace of tn, t to the power of n, and that gives us n factorial over s to the power n plus 1. So that, let's put that in a box. That is the derivation of the Laplace of t to the power of n. Now, let's do an example. The Laplace of t to the power 5. And we can write that as n factorial, which is 5 factorial, because n is 5, divided by s to the power 5 plus 1. And that will be 5 times 4 times 3 times 2 times 1 over s to the power 6, and that will be 120 over s to the power 6. So that is the Laplace of t to the power 5, which is 120 over s to the power 6.